Okay, what we're going to look at now is if we're given a circle, how do you find the equation of that circle? So it has something to do with that distance formula. It's a little nicer to use the d squared version. So basically, if we look at a circle, I've drawn it on the right here. You can see I drew that black point in the middle. That's not part of the circle, but it is really important. So if I can look at the coordinates of that, and it is at, looks like 3 and 2. And so the defining feature of a circle is that the distance to every point on the circle should be the same from this center point. So we say they're equidistant. So for example, if I go down to this point here, that goes straight down by 3. So the distance is 3. If I go across, I go over by 3. I go left 3, up 3. All of those distances should be the exact same. And so that's the key feature of a circle. So if I were to try to come up with the equation of this circle here, I could take this formula and basically it would be all of the x's. So I'd write that in blue. So the circle is all, not x's, all x's and y's. That have distance 3 from the point 3 and 2. And so we can actually just plug that into the formula. So if we plug this into the formula, what I could say is that this xy for any point might be my second point. And the point 3, 2 might be my first point. Oh, sorry, this should be a 2 up there. It doesn't totally matter what order you choose, but this one's just going to look a little bit nicer in the formula. And then we have d equals 3. So we should be able to actually put that together to get 3 squared equals x. So yeah, my x2 is x, my x1 is 3, plus, and then my y2 is y, my y1 is 2. And so this would be my formula. We wouldn't want to simplify it or anything. It actually is easiest to read in this format because you can see what the center is. It's this 3 and 2. We can see the radius of 3 on the left. So yeah, one thing you can also do is tie this in with the transformation conversation. A standard circle would be at 0, 0. So a standard circle would be something like x squared plus y squared equals a radius squared. And then what we actually have is 2 shifts. So we're going to shift, if you want to think of this way, it would be a shift right by 3. Remember, it's the opposite of what's in the bracket. And now because y is also in a bracket as well, it's going to have that same sort of opposite shift than what you actually see. So that's going to go up by 2. And that's what we would see here, the shift right by 3, up by 2. So it does kind of closely correspond with a lot of the transformation conversation. But we can just generalize this. Okay, so in general, the circle with radius r and centered at the point AB is going to be described by this equation here, x minus a squared plus y minus b squared equals r squared, right? So in this example on the right, it's centered at 3, 2, so a is 3 and b is 2, and the radius is the distance. So that's kind of just a quick way that we can put these equations together. So I'll do a couple examples. All right, a couple of examples here. So we're going to find the equation in this drawn circle, and then a bit of a word problem, not much of one at the bottom. So yeah, looks like a circle. What we need to do is really find the center to be able to do much with it. So in this question, it's kind of eyeballed, but you'd think I'd give you integers, and it looks like it's going to be right here at -2 and 1. So my center is AB equals -2 and 1. And then from that, we just look at those distances to the outsides. So I think if I go in any direction, that looks like a distance of 2. So my radius is 2. And that's pretty much all I need to put my equation together. So what I'll have is x minus a squared plus y minus b squared equals 2 squared. And I'm just going to clean this one up a little bit. So I'll get x plus 2 squared plus y minus 1 squared equals 4. All right, so I'm just going to get this out of the way to do the next question. It's got a little bit more to it. All right, for this one, so I'll give you a little bit of information here. We know that it's centered at 5 and -2, so that's a good piece of info. This tells us my AB is 5 and -2, and its highest point is at 5 and 4. So you might be able to figure out the radius from that without drawing a picture, but I am just going to go ahead and draw a picture to get a better idea of this. So I need to go over a little bit to get that x equals 5. And I'm going to go down to -2. So this will be my center. And then the highest point is at 5 and 4. So that's going to be a point that's actually on the circle there. Again, you might be able to figure out the radius from here, from just looking at that. If you choose to go a little bit further, maybe try to draw the circle. I don't know, that looks okay to me. But the important thing is seeing that radius. You definitely see that right there. That is the radius, and since it does go from 4 to -2, that would be a radius of 6. And again, you might have been able to figure that out from just saying, well, that's, those 2 points, one's the middle and one's a point on the circle. The distance between those 2 points is pretty easily calculated. You could have even used the distance formula, but that one is just because the x's stay the same, it would just be the difference between 4 and -2. But yeah, we have we have AB, so we're going to put it together. X minus 5 squared plus y minus -2, so plus 2 squared equals 6 squared, 36. And that's our equation of the circle. Yeah, so up next we will just go reverse. So drawing a circle from the equation. It's basically just going backwards. There's nothing really tricky with that.